In this interactive simulation, we can view the electromagnetic spectrum and we can see what happens as we scroll through the electromagnetic spectrum. So the electromagnetic spectrum is made up of all electromagnetic waves. We have radio waves down here where the wavelength is very long. So we have wavelengths of order 10 to the fourth meters. And then at the other end of the spectrum, we have gamma rays where the wavelength is very, very short. So as we look at this, and we see, of course, the visible light is a small portion of the electromagnetic spectrum. So as I take and I scroll to different areas of the electromagnetic spectrum, we can see what happens to the frequency and the wavelength as well as the speed. So the first thing we're going to consider is what happens as I scroll through the electromagnetic spectrum. Watch what happens to the speed of the electromagnetic waves. And so no matter where I go on here, the speed of the electromagnetic wave stays exactly the same value. So all electromagnetic waves travel at the same speed, and that speed is the speed of light, which is 3 times 10 to the 8 meters per second. Next, we can look at what happens as the wavelength changes. So let's start off at a small wavelength down here, and let's consider what happens as we increase the wavelength, what happens to the frequency. So right now, the frequency of gamma rays is quite large. It's 3 times 10 to the 23. And as I scroll through and I increase the wavelength, the frequency is getting smaller and smaller and smaller. So by the time I'm over here near radio waves, the wavelength is quite large. It's 1.45 times 10 to the minus 2, but the frequency is now of order 10 to the 10 hertz. So small wavelength of order 10 to the minus 16 has very large frequency, 10 to the 24, and as the wavelength increases, so over here I have a pretty large wavelength, 3.16 meters, or 3.16 times 10 to the 1, I have a very small frequency. So as the wavelength increases, the frequency decreases. As we look at this, we realize also that visible light in this range right here makes up a very small portion, very tiny amount of the entire electromagnetic spectrum. As we look at this, we see that radio waves have the longest wavelength and the smallest frequency, and gamma rays have the shortest wavelength and the highest frequency. The energy associated with an electromagnetic wave is directly associated with its frequency. So the higher the frequency, the more energy that electromagnetic wave carries, which means that gamma rays carry the most amount of energy, and then of course followed by X-rays. And as we move down, radio waves carry the least amount of energy.